Hello, Professor. In this presentation, we will present about the Progress3 of our paper-based microfluidic project. Me, ชัยดาอยู่ร่วม and my partner อัชราเทพบุตร with our project advisor Dr. พิมขวัญ หันนันทอนันต์ For the plan that we expect in the week 3 to 4 of month 2, we will confirm about the flow rate and the time interval of the first prototype.And in the week 1 to 2 of month 3, we will adjust the first prototype. For the thing that we have done, in week 3 to 4 of month 2, we optimize the heating temperature and heating time. And in the week 1 to 2 of month 3, we heat the filter paper by using the oven. Due to the result that using the hot plate, the filter paper was burned. From this video, we try to find the optimal heating temperature and heating time to get the complete hydrophobic barrier. First, we try to binding the prototype on the doubling 102 filter paper for 3 times and 4 times, and heat them at 190 degrees Celsius for 30 minutes.45 minutes and 1 hour respectively. For the result, we can observe that the prototype that is printed for 3 to 4 times in 1 hour has the best result due to when we test by drop the distilled water on the channel, the distilled water can permeate through the hydrophobic channel without leaking out of water.But there are some problem that is the filter paper was burned. Therefore, we will try to use the hot air oven instead the hot plate to solve the problem.
Solve the problem that we got from the previous week by heating the filter paper in the hot air oven instead of using the hot plate. We need to optimize the heating temperature and heating time again.by setting the heating temperature at the same as temperature that we use while we heating the filter paper on the hot plate, which is 190 degrees Celsius, and then vary the heating time for 30 minutes, 45 minutes, and 1 hour respectively. And for the result, as you can see in the slide, this is the 3-time binding hydrophobic barriers on the filter paper.All of these conditions, the filter paper didn't burn, and then we taste by dropping the distilled water on the filter paper. All of these conditions cannot contain the distilled water inside of the hydrophobic channel. So I can say that even though the filter paper didn't burn, but we cannot use this condition because it cannot contain the distilled water inside the channel. So it's not a complete hydrophobic barrier. And next is the 4-time binding. The 4-time binding had the same result with the 3-time binding, which is the filter paper didn't burn, but it also cannot contain the distilled water inside the channel, so both of condition cannot use in our project. Then we try to figure out again how to optimize the heating temperature and heating time to create a complete hydrophobic barriers on the filter paper by using the hot air oven.Then we change the heating temperature to be 260 degrees Celsius because at this temperature is the melting point of the polyester. The polyester is the main ingredient in the printer ink, and it can create the hydrophobic barriers on the filter paper. So if we can melt it and sink it through the paper, so it can may create the complete hydrophobic barriers. But at this temperature is too high, so we need to decrease the heating time to be 5 minutes, 10 minutes, and 15 minutes respectively. And for the result, for 3-time printings and heat with the 260 degrees Celsius for 5, 10, and 15 minutes. For the 5 heating time, is the one condition that the filter paper didn't burn, but for the 10 and 15 minutes, both of these filter paper has more darker color, which means it's burned. And for after we taste with the distilled water, the 5-minute heating time cannot contain the distilled water at all, so we cannot use these conditions. And for the 10-minute heating time, it can contain some and some still leak out, so yeah, we cannot use this one too. And the last one is 15-minute heating time. For this condition, it can completely contain the distilled water inside of the hydrophobic barrier by not leaking out. So I can say that this is the best conditions for create the hydrophobic barriers in the hot air oven. And yeah, for the 4-time printing, it's the same as with 3-time printing, which is 5-minute heating time cannot contain the distilled water, 10 minutes can contain some and some still leak out, and 15 minutes can completely contain the distilled water inside the channel. So for the conclusions, the filter paper that we heat on the hot plate with 190 degrees Celsius for 1 hour, and the filter paper that we heat in the hot air oven with 260 degrees Celsius for 15 minutes are the best conditions for create the hydrophobic barriers in this time. But we have the big problem is the filter paper still burned after heat, even though we heat it in the hot air oven. So in the next progress, we will change the filter paper to decrease the pore size of the paper and then sink it through the filter paper more easier, and then we may decrease the heating time to avoid the filter paper burning. And we will also try to change the printer to become a thermal transfer printer, because can create the greater hydrophobic barriers on the filter paper than the laser printer. And the last one is the video clip of our result while we are doing the experiment. Thank you for your attention.